Fichtner is an engineering consultant at heart, and therefore it's a nice change of pace for me to be able to speak about a big picture today, as Theresa already introduced. And that big picture is, as you're all aware, that humanity has set the goal of achieving net zero. And if you think this through, this means that we have committed to actually changing large parts of our world in the next 2.5 decades. And the question I want to discuss today is obviously, which role will green hydrogen and green hydrogen-based chemicals play in this transition, in my view, and in the view of Fichtner. In the last 3 years, Fichtner has worked on more than 60 projects in the field. And as a result, I've had the chance to speak to many people around the world about hydrogen. And I was able to think about and learn a lot about the role that green hydrogen can play in achieving decarbonization. And my personal result is green hydrogen-based chemicals are a cornerstone of achieving decarbonization and changing our world. I'm fully aware that this is a bold statement, and to me it is a bit like what Steve Jobs once said: the people who are crazy enough to think they can change the world are the ones who do. So in my presentation, I want to explain my and our thinking at Fichtner, and my wish for today would be that after the presentation, you would not consider people crazy that think that hydrogen has an important role in changing our world on the way to net zero. And with that, I will share my screen and hope that this works. Could you give me a quick feedback if you can see my screen?
Sure, yes, we can see it, but yes, perfect.
That's a good start. Perfect. So having made my introduction, I want to quickly introduce you to Fichtner in the field of hydrogen. Fichtner in general, as on a general view, is Germany's largest engineering and consulting company in the energy sector. We have a long history of hydrogen dating back to the early 1990s. And obviously of those 30 years, the last 4 have been the most exciting ones. Hydrogen has grown, our team has grown. We have done more than 60 projects total in over 15 countries in those 15 years, starting from business models and consulting for politics, helping companies and countries develop over 50 projects in early phases. As you can see, also large-scale projects up to 4 gigawatt. And most importantly, we are involved in plan and projects, or as engineers, projects that are actually being built. The largest one at 100 megawatt, and the most advanced one will go into operation later this year. So why do we think that green hydrogen is an important driver for decarbonization? To understand this, I think we must first understand the challenge of net zero. What you see here are the global greenhouse gas emissions and how and in which sectors they are caused. And usually when we talk about decarbonization, for the good part of the last 2 decades, we've been talking about the power and heat sector. But what's important to notice that represents only a quarter of the problem. The other sectors, like industry, like agriculture and forestry, or as we've already heard today, transport sector, contribute together the lion's share of greenhouse gas emissions that we have in our world. And this means if we want to achieve net zero, we don't have to only decarbonize power and heat, we have to decarbonize all these sectors. So let's look at the energy consumption leading to CO2 emissions, these CO2 emissions that you see here. On the next slide, I'm going to show you the final energy consumption of the European Union as an example. Final energy consumption means the energy form that consumers use. And what's striking to me is that, again, the electricity sector is only around a quarter of the energy that we consume. And this is pretty representative for all over the world, although it's a European example. And we've made progress decarbonizing the electricity sector with renewable energies. But I think what becomes clear if you look at this slide is that if we want to get anywhere near net zero, we need to decarbonize this large dark blue block on the left-hand side of the slide. That's the chemical energy directly used by consumers. What are examples of this? One example is the natural gas that we use to heat our homes. And as Europeans and as we Germans, we are currently being reminded how much gas we actually consume. It's mobility, not only in the transport sector, but as we've heard, in the shipping sector and also in the aviation industry. And finally, industry. We make steel, ammonia, concrete, the things that we build our world from and that we consume every day. And roughly each of these sectors is around 20% of final energy use, so a third of that big dark blue block. So if we want to decarbonize these applications, and if we want to achieve net zero, we need a chemical energy source that is carbon neutral. And this is where hydrogen comes into play. What can be hydrogen used for? I think the most prominent use is the direct use. For example, in fuel cell mobility, as I've shown or as I've indicated in the heat sector, also in the power sector. This is where the conversation usually starts, but it's so much more, as you can guess. We've heard about fuel ammonia for ships, but there's an interesting development for fuel ammonia going on in the market these days. If you look at the East Asian countries, especially Japan and Korea, they have an existing thermal power plant fleet that cannot be replaced in line with their emissions reductions targets. And these countries are actively pushing for contracts, for purchase contracts and MOUs to buy fuel, green fuel or blue fuel ammonia on the world market. A lot of hydrogen that we produce today, and we produce a lot, as I will later show, goes into ammonia production and into fertilizers. And as this sector needs to decarbonize, as we've seen in the emissions for agriculture and forestry, ammonia and green hydrogen used to produce it becomes relevant. We've already seen green methanol. It's a chemical already in use, not just a potential for future decarbonization of transport. It can also be used to produce synthetic fuels. For example, the airplane stock is not going to disappear overnight. The combustion engines that we are still building and selling every day, all those things have an economic lifetime. And in the transition period until, let's say, 2040, 2050, synthetic fuels can play a huge role in decarbonizing these sectors, as international projects show, which I will present later. And finally, consumers are demanding more and more sustainable products. And this makes green building materials, not only in construction, but also for cars and for appliances necessary, which has the steel industry running to decarbonize. So you see, hydrogen actually can have a role in decarbonizing many of the physical sectors of our world. And these sectors are considerable in size. And as a result, we've seen a rapid development in the green hydrogen project pipeline supplying them. This slide is an example I usually use trying to illustrate the dynamic growth that we at Fichtner have seen and that the world in hydrogen has seen. If you think back around 5 years, a project that people were quite proud of to announce was the Lighthouse project, power to gas in our home state of Baden-Württemberg with a 1 megawatt electrolysis. A year later, the Heide refinery in Germany announced the largest PEM electrolyzer in the world to be built with 10 megawatts. A year later, the German natural gas and electricity grid operators got together and announced 2 100 megawatt projects. And in 2020, the first gigawatt project announcements started with Norge H2, with HIF synthetic fuels in Chile, also blue ammonia from natural gas from Norway with H2morrow. And finally, in 2021, Fortescue Future Industries announced a portfolio in the tens of gigawatts. So you can see project sizes have grown by a factor of 10 over the last 5 years each year, and that is a remarkable development. And it shows how much potential industry sees in the field of hydrogen. And it does not stop at the announcement of production projects. They are part of an integrated value chain forming across the globe, as we've heard in the introductory remarks. And this means that the countries that are commodity exporters today are positioning themselves to export green chemicals in the future. A couple of examples, and this is by no means complete, but just an illustration of the dynamics, is what you can see on this slide. For example, Australia, a country exporting coal and other raw materials. Australia is positioning itself very actively as a green and blue hydrogen supplier to Japan, the rest of Asia, and the world. Chile, on the other end of the world, a country with a well-established mining industry. It has a very ambitious green hydrogen strategy, and it intends to use its great renewable resources to export green chemicals to the global market in different forms: ammonia, hydrogen, and synthetic fuels. In Saudi Arabia, an oil exporting country, with NEOM, this country has an advanced green ammonia project at gigawatt scale, aiming at the global export market. And other examples in the region include the United Arab Emirates and Qatar. And what should not be forgotten, which a country that you see here in the very north of the map, Norway is one of Europe's main gas suppliers still, and it is actively developing the supply of blue hydrogen to Europe. And for the exporting countries, this is a chance to enlarge the value chain as well. The example of Saudi Arabia is a good one. Currently, it's exporting mainly oil, a raw material, and with green ammonia, it would export a finished product instead. In addition, the Ukraine war has intensified the energy import discussions for Europe. As you are probably aware, our German Ministry of Economic Affairs is currently visiting various countries in search for LNG quantities. And in all those talks, green hydrogen is a topic as well. So you can see that hydrogen is being taken serious, and it is required to change large parts of our world that today use fossil fuels to generate its products. At the beginning, I've said that hydrogen can be a significant part of changing the world. And therefore, I want to close with an illustration of how large this impact can be. You may be aware that hydrogen is an established product today. We produce 70 million tons of it already. This is gray hydrogen to the absolute majority. And with a cost of $1,000 or $1,500 per ton, this equals to a $100 billion a year market. And the carbon footprint of this sector is roughly the same size of Germany. And this sector needs to be decarbonized. However, what I've just shown you and what people mean when they speak about green hydrogen and its potential, they mainly think of something different. They think of replacing fossil fuels. And this market is significantly larger. As a rough estimate, it equals 5 trillion tons of hydrogen per year. And certainly other things will take a share of that potential market: energy efficiency, electrification of applications like e-mobility, and on and so forth. But even capturing a share of this potential is enormous and a fundamental change to our industry and the world. And as I've shown, I do believe that this is required and is actually inevitable if we want to achieve net zero. And therefore, I do believe that green hydrogen-based chemicals will drive decarbonization and change how the world looks like in decades to come. And finally, I would like to refer you to our website if you want to know what we do in daily business. And I want to say I look forward to discussing with you and my co-panelists later today.